Okay.
Welcome to Examining Evolution. I am here with Speed of Sound. He has a channel called Answers in Atheism, and he talks a lot about the creation evolution debate. And he wanted to come on and share his reasons for believing in evolution. So, Mike, welcome and glad you're here.
Hey. So part of this is there's a feeling when people talk about it, like when creationists talk about atheists and evolutionists, they call us, right? There's this feeling that we're this gaslighting sort of feeling, or this feeling that you get when somebody misrepresents you so badly that you look at them like if you've had a friend that thought something about you that is so not you, that suddenly you start doubting whether this person ever really knew you at all, that sort of thing, right? So that's part of it, this idea that oh, you just want to believe in evolution because you don't want to believe in God. That's one of them that makes zero sense to me. And the other one is you just want to believe in evolution so you can sin, or all of these little straw men, things that come. You know what I'm talking about, right? You've heard this stuff, this rhetoric, and I always like to examine why I believe in something. Like if I believe something about a political situation or something bad about somebody, what I like to do is go sit out in the chair out in the woods and pick apart each little piece of information that I have and ask myself, do I believe that? Do I believe that? And take a look at, what contributes to the belief overall. And there's a little bit about belief that, and I may have looked into this more deeply than a lot of people, but belief isn't something that's floating around somewhere inside your brain as a uh, cohesive whole, right? Like I have this belief tucked away up here. At least most beliefs aren't like that. You'll sit here and I'll think, like if I think about the objects in my room, okay, or in my house, I know I have 11 little baby willow trees upstairs, and and the minute when I think about them, that's when the belief is formed. That's when I pull in the information from my brain, but I don't pull in a lot of facts or look at it. I don't look at it that analytically. I just sort of accept, yeah, those little 11 baby willow trees are up there in my 3-season porch growing away. And if I were to start to examine all the reasons that I believe that, it's, well, I saw them yesterday. Okay. Well, I have a memory of seeing them yesterday, and I know that I planted them, and it's not surprising that one would have willow trees growing in your plant room, right? That's sort of all that stuff, right? So when I look at my history with evolution, I think it might surprise a lot of you. Uh, I grew up in the North Woods, and I grew up on a farm, and I was a middle sibling, and my siblings were they didn't want anything to do with me. They were in school, or riding around in cars, riding in cars with boys, or so I played alone, and I played in the woods primarily. And I became very, very fascinated with the structure of plants. So to me, I would go and look at one species of plant, and then and look at how the leaves were shaped and all the different colors on it. And in particular, I would pay attention to how the thing smelled or tasted, if it was the kind of thing that I could put in my mouth, right? And so I became very fascinated with this diversity in nature. And then I'd go look at another plant, and it's like, wow, this is totally different, a different shape. And then I'd start looking at each plant, like one species, and I'd notice that every plant was an individual within that species, and every one had its own little quirks and differences and different ways of growing and branching. And I was amazed with color and complexity all my life. So basically, I fell in love. I always say that my God is complexity, right? So then, right around the age of between 8 and 13, I became very heavily interested in science. And around 10, 11 years old, I discovered organic chemistry. And I found out that molecules hooked together like Lego blocks, so that carbon chemistry was also very complicated. I could draw one carbon atom and then another one and then another one, and then I could branch one off of that, and then I could make a little ring. And it's like, oh my God, I can. So I became obsessed with developing algebraic formulas for how chemicals hook together. And I was trying to develop this great theory, and I was like, I was pretty dumb at that age. I mean, I wasn't, I wasn't ready. I wasn't ready to be doing any heavy mathematics or any heavy lifting in the theoretical science world, right? So a lot of the stuff I came up with was, sort of sad and naive, and I never really got anywhere with my ideas. But I became completely fascinated with all of that. Now, at the same time, religion. Okay, I was introduced to the Presbyterian Church from the age of 6 to 8. And the Presbyterian Church, to me, they talked about, like on Christmas, they talk about stories about Jesus and all of that. But it was kind of like the same stories that when my parents told me about Santa Claus. They didn't really focus on that in the Presbyterian Church I went to. It was a town of 3,000 people. It had an older minister named Reverend Peterson, who mostly talked about how we should care for each other and love each other and, morality, right? And community. And so it seemed like kind of a community thing, and there wasn't a whole lot of dogma involved. And, as far as the belief in God or any of that, it just never struck me as anything by the time I was 10 or 11 years old that I would ever even consider was real. So I didn't have that, right? So basically religion and science had nothing to do with each other as far as I was concerned. I was more fascinated with the material world, the world of complexity. And then as I went through high school, the biology books, I don't think they ever had the word evolution printed in them. Not one of them. I do have, I think I somewhere out in my pile of books, I have that my very first biology book, which I got when I was in 4th grade. My teacher got a hold of it for me from the 11th grade biology teacher. And I don't think it says evolution in that entire book. And it certainly wasn't mainstream, and it wasn't anything we considered. So if I were to wonder, how I got, and I'm sure I heard about, the stories about, we came from, we're related to chimpanzees and all of that. But I didn't really give a rat's ass, to put it bluntly. I mean, it didn't really ever, it wasn't something, it was something that I would say that I believed in, I'm guessing, if you asked me that question. But as to why I believed in it, I don't think I had any reasons at the time. And I didn't really ever question it, I knew that the natural world could create all of this complexity. So one of the things that I did is I took that love of plants and diversity in plants and how they smelled and how they tasted. And I started looking into something called phytochemicals, or, plant chemicals, basically is what phytochemical means. It's just a 75-cent word for plant chemical. And I started finding that in onions, there was one kind of chemical, and then in garlic, which really kind of smells a little bit alike, there's a similarity between onion and garlic. There's a very slightly different chemical. So if you just tweak those atoms a little bit, you end up with an entirely different flavor and smell. And it was that way, and I started looking at all of these complicated anthocyanin rings and just all of these things that made purple colors and caused leaves to turn colors in the fall. And I became thoroughly fascinated with all of that. And that's kind of how I came up. But one thing I saw is that in these plants that looked alike, they had chemicals that looked alike when you drew the structure. So there was this homology. So it seemed like somehow things had come from a similar source, right? So here we are looking at, the possibility that one plant evolved into another. And I don't think I formulated it in my brain any further than just being in love with the similarity, right? So then I went through my entire middle years learning how to program computers, studying organic chemistry and mathematics, and mostly computers. So I became a computer programmer, and I kind of left it. Around the year 2000, 1999, 2000, I discovered. Have you ever heard of evolutionary psychology?
Mm-hmm. Definitely.
So I hit evolutionary psychology, and I absolutely loved it. I read Steven Pinker, and I forget what is it, Mark Ridley, and Tooby and Cosmides, and just all those people, and I so I got really far into that, and I became fascinated with the idea that our psychology evolved out on the savannah somewhere was the story. And I heard all these stories about how things evolved, or how we ended up being the kind of critters that we are, caring about the things that we care about. But then I ran into a couple of things. Somebody asked me about a memory, where your memories are stored in your brain, and I didn't know. I didn't understand it at all. I had no idea how memory is stored in the brain. And I also looked at, there was this thing that males across 35 different civilizations prefer females with a 0.70 waist to hip ratio, right? We love it for some reason. And it turns out, that this particular S shape, and then, I'd look at females and I'd say, yeah, I like it too. I like it, right? It's just like, it's perfect. And I started asking myself, how could genes create a brain that would pick out a 0.70 waist to hip ratio? And I became very skeptical about how this could happen, right? And nowadays, people really hate evolutionary psychology, but I don't. I don't think they understand what it is. The people that hate it, they didn't quite approach it in the way I did, where it's like, okay, fine, you can tell your story, but you show me how it happened. And tell you the truth, I never did find out about the 0.70 hip ratio. And hence, I'm still very skeptical about that one, because I don't know how that developed. I don't know how that happened. So I still haven't come up with a really good story about how it happened. But anyway, so then I got into neuroscience. And I was already into molecular biology from maybe 1998 on. And I got into neuroscience pretty heavily, but oh my goodness, I'm sorry. But at the same time, I was using drugs and alcohol, so I wasn't progressing very quickly in any of this. And then at about 2007, when I sobered up, I got into neuroscience, and I got into the online community and in forums. And the big thing there were no creationists. Well, there were a few creationists or anti-evolutionists or whatever. But for the most part, there were these other kind of people. They believed that the world was made of mind, that consciousness couldn't possibly be physical. Oh my God, she won't go away. That the world couldn't be physical, that it had to be, it had to be something supernatural, right? That consciousness had to be supernatural. So I went to work on neuroscience for probably about 5 or 6 years until in neuroscience and the philosophy of mind, until I got a really good understanding about how the mind is physical. And I put together every single little tiny circuit and started looking at it from many, many different angles, and read a tremendous amount of books, which I have shelves of over here, on neuroscience and on molecular neuroscience, that sort of thing, and satisfied myself about how it worked, right? And then I kind of got out of the forums, and I stumbled into YouTube in around 2016, and I found these creationists, and I'm like, what are these things? What in the hell are they talking about? And I'd run into a few on forums and stuff like that. And it's like, I didn't know you guys existed. And I was quite amused. And so I started watching Matt Dillahunty and, Atheist Experience. And, and there's this big war between religion and, and all that stuff. And so I got introduced to that. And I got fired up. on my side of the thing. And it's like, oh, you evolutionists, you're idiots, you don't know what you're doing and all that stuff. And so I became probably around 2015, 2016, I think is when I started plowing into evolution. And I didn't do it really, really seriously until 2016, where I started to actually educate myself in evolution. Like, I want to know how this stuff happened, right? And started learning about genetics and all of that. And up to that point, I didn't have any other way for it to happen because I'm not a believer, right? So it must have happened naturally. So if you'd ask me, do I believe in evolution? I'd say, yeah, I believe in evolution. If you'd ask me why, I'd say, well, I'm not really sure why. It's just I have no other way it could have happened, so I don't really know. But then you guys challenged me, at every stage. Every time I heard the creationists come up with an argument against evolution, I would go and pull 25, 30 papers and plow into it until I understood why you were wrong. And if I didn't understand why you were wrong, I would have kept pulling papers until I did. So every one of these little one-off arguments that I find from SFT on ERVs and whatever, I'll go pull all these papers and I'll start to find the mechanism. But there's something interesting that happened probably 2018, something like that. I started thinking about how zygotes turn into human beings or elephants or oak trees. And I'm like, I'm really skeptical that that could happen at all through natural means, right? Yet even you believe it happens through natural means without supernatural intervention, right? You believe the code was made by something supernatural, but the code is just a string of just a sequence of chemicals strung together, right? And somehow that particular sequence of chemicals turns into a fully formed human being from a little tiny clear egg, that if you were to look at it under a low-powered microscope, it would look like a sack of water, like nothing in there, nothing happening.
It's amazing. Mm-hmm.
Yes, it's amazing. So how could that happen? So I started looking. So I got into embryology, and my question was, how does a limb form? How do you get these fingers? And how does it make the knuckles and know where to attach the muscles and the bones and all of that? And it's like, what kind of genetic instructions? Because I'd look at the genome, and I knew a lot about the genome at that time. And there was nothing in the genome that told you how to build an arm. Nothing that you could read it and say, oh, here's where you hook this up, and there's where you hook that up, right? And so I think my skepticism over evolution does not manifest itself in disbelief that it could happen, but rather it manifests itself as a humble understanding that I do not understand how it works. Do you understand the difference? Okay, instead of saying, okay, I don't know how something happens and I can't imagine it, and I am very skeptical about this happening through natural means. But I don't go to, oh, then it can't happen. I know it can't happen. No, rather I have a humble understanding that I do not understand how it happens. Do you see the difference between those two things?
Yeah.
Okay.
But the thing is, you are accepting the story of evolution as the explanation, where I'm not. You are accepting it.
No.
So the whole title of this video is why you believe in evolution, right? So
yeah, and when you like I told you, when you believe in something, you're like, yeah, I guess I do, but how committed are you to that, right? Unless you actually know how it happened. So
right.
most atheists will say, I believe in it because I don't know an alternative, but at the same time, I don't know how it happened, so I don't understand how it works. So I, if you press me on it, I'm going to have to get back to you on it, because I got to tell you how it happened, because I can't completely justify my belief unless I have that understanding.
Okay. So what would cause you to favor the idea of evolution rather than God created?
Okay, number one, I have no history, no belief with God. To me, God is no different than any other adolescent looks at Santa Claus or the fact that he believed in Santa Claus. So you understand, I'm devoid of any religion, right? So I don't have that as part of my background. So that's not there. So what do I have? So I have naturalism. So what did I tell you about my youth? I spent my youth. I was a weird kid. I used to sneak out in the middle of the night and I would crawl around the woods, like on my belly, and I would play out there in the woods amongst trees and animals and stuff in the dark. And I would imagine all this complexity around me, right? So I was already committed to complexity as a sort of a God, right? So that was my God, complexity, and the diversity of life and nature and the world around me. I did the same thing with geology. I would look at rocks, and I would, my parents bought me a microscope when I was very young, and I would look. I would be down on my belly all of the time looking at bugs on the ground and stuff like that. So that was my God. So why would I reject that?
So are you saying that your belief in evolution is faith-based, not evidence-based?
Faith?
Well, you're saying
No, I
it's
don't
something
define
you
faith.
believe because you don't believe in God.
I don't describe faith that way. I would describe it as, I would call it intuition based. Okay. Intuition based. Faith is a totally different thing. Faith has nothing to do with belief. So I would call it intuition based. That's based on the best that I know about how the world works. Okay. This is my best intuitive guess as to how things happen. Right. But that's not the case anymore because I started studying embryology. And when I studied embryology, I found out about these cells and how genetic information works together with the existing cell to create an organism. So I found out how an organism blooms, like a flower blooms. I found out how an organism blooms. And what I found out is that the instructions to do that were nothing like I had originally or naively thought they were. That I would find a place that tells me where to bolt this knuckle on, right? Or how long to make that finger or whatever. I found this interplay of complexity again. I found this dance of complexity, and it was based on things that were a lot simpler than what it constructed. So the rules to construct the limb were a lot simpler than the limb that it ended up constructing, which is counterintuitive because if you want to design a space shuttle, the space shuttle is a lot simpler than the blueprints to create it, than the information in the blueprints to create the space shuttle. When I design a computer program, okay, the design of the computer program consists of, like notebooks or pages in my head or whatever. And the actual computer program is a lot simpler than that. It's just some simple instructions about, what the computer should do. Turn left, turn right, right? So the design of human things are much more complicated than the thing that they create, okay? But it was the reverse in biology. The design that created the cell was a lot simpler than the cell that it created. And that's what I discovered in embryology. And so then so then I went and started looking at things like the challenge. I could not understand how a fin could turn into a limb. But in the process of understanding embryology, I realized that if you just tweak this one protein just a little bit in its concentration, that all of a sudden, instead of an item like that, it goes like that and wraps around and creates something much more complicated just by this simple tweak. And so these simple tweaks, and then you go back and you start looking at evolutionary theory and genetics, and what do they tell you? They tell you there are simple mutations in these proteins. There are very simple changes in the concentrations of the proteins, in how long they are transcribed, or what the concentration is, and all of that. So all of those things started to add up to it's still an intuition because nobody can grasp all of the information. And, like this is Dan Grar's molecular genome evolution book, right? I mean, I can learn the whole thing and put it in my mind, but I can't grasp it at once, right? So we always have an intuitive belief. I mean, beliefs are always, at the end of the day, they're based on your best intuition about how something could happen. So like for limbs, for Cell mentioned mammary glands, I run into my kidney cancer. I had to know how kidneys evolved. I had to know how livers evolved. I had to know the steps that those tiny little steps, right? As fine as I could. I can't tell you the whole story, and we can't ever tell you exactly what the history of it was. But what we can tell you is that every little step between point A and B, we have observational experimental evidence that step can happen. That we have. And that's what you seem to deny.
Well, I would challenge that, but I would also challenge
What would you
that
challenge?
I don't think we have every little step. But even if we did have a story for every step, what we would actually need is evidence that it actually happened. You can come up with a path, but why? Well, if we're calling it science, now you're saying you believe in evolution based on your best intuitions. So my best intuition is that God created. Should I follow my best intuition?
Okay, so you find a guy, you're a police officer, you find a guy, he's got a bloody knife in his hand, and they're down the street a block away. His shirt is covered with blood. It happens to be the victim's blood. You find the victim is stabbed. Did you see him stab the victim?
No.
Did you observe him stab the victim? Okay. So what is your evidence that he stabbed the victim?
Well, I mean, the blood and the murder weapon is a good piece of evidence.
Okay, that's the evidence for evolution. It's the same way, Rebecca. I don't know why you guys don't get this. We know that mutations can happen. We know that ERVs and transposons can transpose. We've actually measured that in the laboratory. So we know each little tiny step, right? And then you go ahead and you look at you put all the little steps together. You've got a body, you've got a thing that happened. Okay, and then you break it down into all the little steps. And if any of those little steps are impossible, you have falsified your theory. How do you falsify your theory that it didn't happen that way? What evidence would falsify your theory?
Well, I don't know. I don't know about falsifying my theory because my theory is a supernatural event occurred. So right. I don't know how, but the point is with regard to mutation, right? Our observations on mutation are generally evolution is going in the wrong direction.
Who told you that? But show me a paper that
my best buddy Sal and all the other creationists that. So I mean,
so your evidence is Sal told you.
Well, no, I mean, if you have evidence, if I'm wrong, please, I would love to see the evidence. So that's what this channel is about. Now, so far I haven't really been presented with any evidence that would be compelling reason to believe that this process of mutations that, is in general flowing in the direction of degrading organisms, but that somehow miraculously in the past, it was going in the opposite direction and just building up all these like fantastic systems within organisms.
Okay, what do you mean degrade? What organisms are degrading in front of you right now? What organisms do you know?
Well, let's start with humans. Let's take humans. We're collecting mutations that are harmful every generation.
Who told you that? Where's your proof of that?
Mike, if you're challenging that, then let's bring the evidence, because
Yeah,
I
okay.
can start naming sources, but okay, let's talk about, okay, if I wish I had my stack of books here, but I'm just moved, so I don't. But how about Michael Behe, Darwin Devolves? That's a good source.
Why is that a good source? What is your evidence that humans are devolving? Humans are changing, I'm guessing, but not too rapidly. But have you ever driven by a playground where there are some young children running around playing? Do they look devolved to you compared to you? Do they look like they're mutated compared to you? Do they look like they're defective somehow? What is your evidence? No,
Well,
I've heard.
mutations are happening at a level where you may not be able to see the full effects, right? But
Right,
um,
right, but
so
that doesn't affect our overall, basically the health of the species for a
well, more
number of
kids have
different reasons.
autism now. More kids are we are
Have you
gaining.
checked into that? Have you looked that up to figure out why more kids are being diagnosed with autism right now? And have you looked up the fact that only white middle class kids are being diagnosed with autism, and in other countries and in other economic tiers, the diagnosis is not increased? And did you also know that we have widened what that diagnosis is? We call it the spectrum now. Do you know why we do that? Okay, that's one thing. Another thing, standing for truth, I'll tell you, is cancer. So I looked up the numbers on the Cancer Society. Apparently, cancer peaked in 1989. There's only one cancer that looks like it was increasing, and I think that was prostate cancer, and that was correlated with an aging population. And so cancer is not on the increase.
Well, I mean, there of course there's lots of environmental factors that can affect cancer. I mean, people were smoking heavily in the United
We
States.
didn't have catalytic converters, right?
So, and yeah,
Why
so
would it go down?
basically there's a lot of factors that can affect cancer. But anyway, this stream is about why you believe in evolution, so we can get back on track.
Right. Okay. Anyway, but it's things like that. Like when I heard about that cancer's increasing or that we're mutating or whatever, what did I do about it? I Googled it. I dug up papers, and I didn't just Google news articles, because there's a news article about I forget what his name is, but he said that humans are becoming IQ is dropping, right? So I looked on page 1 and page 2 and page 3 and page 4 of Google, and guess what? A lot of people don't agree with those particular studies, and there are about 50 reasons why that guy was wrong. I forget what his name was. He wrote a gigantic paper on why humans are getting dumber, right? And at the end of the day, it's not even something you can measure across a population, let alone believe the bogus tests that he did, and the bogus information that was coming out in the press. So anyway, so I rejected that one. So then, okay, but you see what's happening here. Every time you guys come up with something that challenges me, I go out and dig it up. And guess what? Every single time I dig it up, I find out that, well, it's either way more complicated than that. There are no clear answers, or you guys are just plain wrong. You plain didn't read deep enough. You didn't look far enough. You didn't do your research. And that's what I keep finding over and over again. And the more I find that, like this morning, okay, I was reading about viruses and mobile elements, right? And there was, what was it? I forget what it was, but it was this bit that, they're finding this tremendous functionality for all these mobile elements. Well, then I found a guy who actually added that up for me and said, "What do you mean? We have 50 million mobile or 18 million mobile elements, and we found functionality for like 100 of them." that I can find, right? And it's like, okay, we got 100 divided by 18 million. Well, how are you going to call that 100% functional? So I mean, like over and over again, I keep finding these new pieces. And then the other thing is looking at the more I learn about genomics, okay, the more I find that mutations, and it's probably a bad idea to call them mutations. We should call them change. The more I find that change can construct new complexity. And I find that over and over and over again, which confirms my belief. So why I believe in evolution is because I went and learned about it. I spent years of, studying 7 days a week, basically, and finding each individual step. And for every challenge I get, I go out and get that information and I find a plausible pathway. I find out that, okay, the guy's hands were bloody, his shirt was bloody, he had the victim's blood on him, he's got a knife, he hated the victim. I can make a really good guess that this is what happened, basically. And I can do that for evolution. And there isn't one thing that you have come up with, or Cell or anybody has come up with, that tells me that it couldn't have happened. So if you can't tell me that it couldn't happen, then we can't falsify my hypothesis. Not until you tell me how something couldn't happen. So that's why I believe in evolution. Period.
Okay.
Because it works at every level. And then the other thing is Cell, standing for truth, all of those guys, they don't know that much. And they're not looking that deeply. And I don't know why they aren't. It confuses me that they never Google, how did this evolve? Instead, what they Google is, what are the problems with evolution? You're going to end up with different search results.
Wait a minute, though. Sal has 5 degrees in science.
In what?
Biology, physics. No. Yes.
No. Well, okay, what's his degree in biology?
I don't remember.
Okay. Emery Moyna has a degree in biology, too. A lot of people have degrees in biology. Okay, you can learn about plants and trees or whatever, I probably had one when I was 10 years old. But, no, that doesn't tell you about molecular biology and genomics and genetics. There's a lot more to it than that. So I don't care how many degrees Cell's got one in applied physics. He's got one in mathematics. He's got, some sort of engineering background. And so I'm not impressed with his degrees, but that doesn't mean what I am impressed with is how much he's learned in the last 5 years about it, right? I'm more impressed with that. But he still hasn't learned enough. So he's still not digging deeply enough. He starts talking about zinc fingers. He's talking about one of them. There are 700 of them. What about the other ones? I don't know. So, yeah, you don't want to hear any of this, do you, Rebecca? You don't want to hear this stuff, do you? You look uncomfortable.
No, I guess, it's just, one thing I noticed is that when you were talking about evolutionary psychology and you were talking about how we got the, how, certain people got the desire for a certain ratio of hips, you were like, yep. I haven't come up with a story to explain that yet. Right. And so I just want to, that's kind of a comment that I wanted to highlight because the reason that so many of us have a problem with evolutionary psychology is because it is stories people are coming up with. And that is also the problem that I have in general with evolution. If you Google how did such and such evolve, you're probably going to get a story.
Everything's a story, Rebecca. Everything. It doesn't mean it's fiction. It doesn't mean it's fiction. Okay. If I ask you, what'd you do yesterday? You're going to give me a story. Does that mean you didn't do it?
Right. But the thing is that, I believe a story, but I'm not calling my story science. See, these stories of evolution are being passed off as science.
Science is a story. Okay, if you look at the science of geology, right? Okay, so like if you look at the construction of the state of Washington, okay, they call it Nick Zentner calls it what is it, a German chocolate layer cake, basically, and he talks about all of these different things. And what they're doing is they're telling you stories, and they'll tell you, well, we're not certain about this story, right? But this story is one plausible way that it could have happened. Okay. And this story will allow us to make a prediction about another part of that thing that we're not looking at right now. If we drill a hole down, if our story's right, then we should find this, this, and this, right? And they drill that hole down and they find this, this, and this, and they say, well, we're still not 100% certain of our story because we don't know what happened over here, right? So we got to go drill another hole. But every hole they drill tells them that this story is plausible. That these giant bits of ocean crust rose up and slammed into North America and created these layers. These I forget what they call them. There's a nice word for it. And then these volcanoes popped up in the meantime, and then these glaciers came in, and there were these floods, these enormous floods that were Noahic in proportion, and all of these things. And they have this big story, but the story is continually being written and modified, right? And atomic bonds are a story. Like if you talk about how the carbon, has a double bond to the oxygen, for carbon dioxide, that's just a story. That's not even really what happens. When you look into quantum mechanics, it's a whole lot different than that. But it still ends up being a pretty damn good story to explain how carbon, burns in oxygen. When you look at like what CO2 is and what CO is and all of that stuff, these bonds are just a story. They're not real. And atom balls are not real. They aren't real little balls, with electrons rotating around like a solar system. That's not what's happening. But we have these stories that are very, very descriptive, allow you to make predictions and come up with intuitions, right? So for geology, we have this long history of how things happened. And the only thing that matters at the end of the day is it plausible? Could it have happened? Okay. And if it did happen that way, if I drill a hole over here, am I going to find some oil? That's what matters. And if the story keeps working out, it becomes more and more believable. Like if you were my, we're good friends and we were supposed to have lunch yesterday, but no, you had an emergency come up and you had to go do this, this, and this, and you told me a story. Okay. And one of the things you told me you had to do is you had to go and work on your jet airplane, and you had to basically overhaul your jet engine on your jet, right? I'd say, I think you're lying to me, Rebecca. I think you just blew me off for lunch. I think you're lying about your story. You wouldn't come up with something plausible, right? But if you came up with something plausible, it's like, and then what if I really doubted you? What if I thought you were really trying to blow me off? And it's like, okay, you said you were out having dinner with John. I'm going to call John up and just, start a conversation and see if he mentions you. So I'm going to double check your story, right, at every step of the way. That's what we do in science. Science is a lot of stories. And when you say just the story, what you're doing is you're using a rhetorical trick to discount the enormous amount of work that has gone into figuring out who knifed the victim, or who, how the German chocolate cake came to be in Washington. I mean, you're using a rhetorical trick, and I don't care for that. I don't allow it. Okay, so just the story doesn't cut it anymore. Okay, it's like it's just a theory. You understand what happened with that one, right? That just the theory stuff, right? Like,
what do you mean? What happened with it?
A lot of scientists really took offense to that, because theories are not just a theory. You can't put just in front of a theory. Theories are working working sets of hypotheses that have been worked on for ages and backed up and verified. So it's not just a theory. Like somebody just had, oh, I have a theory. I have a theory about how the COVID got started, that sort of thing. It's like, no, it's not like that. Not just. You can't put that demeaning little piece of 4-letter word in front of these things and think you're going to get away with something rhetorically. You can't. So, I mean, that's just bad argumentation to call it justice.
Well, I mean, but, you said, well, we check out our stories to see, you would call up John, you would do all these things to check and see whether my story was true.
Right.
So what are some things and you said everywhere we check with evolution, we just find support. Do you think there's anything that contradicts the theory?
Haven't found anything yet. And if we do, that'll be a big deal, if we find something that contradicts it. But haven't found anything yet. So
what do you think are the best corroborating, evidence? What's the best corroborating evidence?
Phylogenetics, the statistical comparison of genomes across animals, basically is the best corroborating evidence that shows what is going on and what's happened to us. Looking at those sequences of letters, that sort of thing. I wonder if I could, not sure if I could explain it, but there's, so we got a pattern of letters, ACTG, right? And over again. And I don't know if you've ever seen any of them. Have you ever actually looked at any like actual genome? It looks pretty funny.
Well, what do you mean? Like a stretch of letters?
Yeah.
Yeah.
I'm trying to, let me see if I pull one up. Where are we here? So open recent. I'm hoping that something recent will actually work. Apologist. Okay. Yeah, maybe that one. So let's see here. Oh, we got iPad notes. Take that out, put that in. Okay, so there's one right there, basically. Okay. Like these are, let's see, what are these? This is a particular sign sequence, for one of those little transposons that Standing for Truth was talking about. And this shows, there's these repeated patterns, right?
Okay.
And what you do is you compare two of them and you come up with homologies, like where everywhere there's a star, it's identical. But if I got a space here, it's not. So like right there, that means that if you look above, one's a T and one's a C. But then you have 3 G's in each of them, right? So this is from the human to the chimpanzee. So basically, there's another one right here. Okay, there's another mutation right there that, is different in humans and chimpanzees. And then when you go down on the end of the thing, and you can't quite see it with the size of my... Okay, on the end of the thing, there's even more of a difference in that the chimpanzee has more repeats. But anyway, so there are 2 mutations between humans and chimps, right?
Well, now wait a minute. How do you know those are mutations and not just natural differences?
A mutation is a natural difference. It's a difference, right?
Only if you assume the starting point.
No, a mutation.
If you assume the common ancestry.
No.
Then
no.
Okay, what is the thing? What shows you that it's a mutation?
Okay, if I have a word, okay, BGKY, okay, that's a 4 letters, right? BGKY. Now, if I have CGKY, we have a mutation between them. One's different than the other. That's all it's saying.
But only if you know what it started as. Do you see what I'm saying? Like, what I'm saying is you're lining these up and you're saying, okay, well, we know they had a common ancestor, therefore we know this was a mutation.
No.
Right.
No.
But what is it about but see, I'm starting from a different starting point, which is God created. So when I see those, I'm not saying this is a mutation. I'm saying oh, this is a natural difference between two different organisms. So
That's just
what about what in this process shows me that this is actually a mutation?
that's just a story that God did it. I mean, that's just a story.
I know, but I'm just saying if you're starting with two different origin stories, right? How can you tell? You're assuming your story in order to say this is a mutation.
No, it is a mutation, whatever story there is. If God did it one way here and one way there, then there's a mutation between the two.
I don't know if you're understanding my question. I'm wondering if someone didn't know the history of these two organisms, how would they look at this lineup? How would they know that one was a mutation rather than just a natural difference?
Okay, there's no difference between those two things. This is interesting. Okay, if God created a chimp and God created human, right? And God put these two things in here, right? These two mutations, this difference between chimps and humans. God put it in there, right? So there's a difference, and we're calling that difference a mutation. It doesn't matter what came first. It doesn't matter whether God did it or whether natural means did it. It's still a mutation. So I'm
But
showing
a
you the
mutation, I mean, if you look up mutation, let me just look up the definition of
difference. You see, I
mutation
think you're getting hung up on that word, and I don't think we should
yeah,
use
well,
it.
let's see. I just want to make sure I'm using it properly. So the changing of a structure of a gene.
From
Okay,
one thing to
that's
another.
a mutation. So what if it wasn't ever changed? What if it just started as a difference?
Started as so they were both created at the same time with the difference. It would still be a difference. It would still be a
Yeah,
mutation.
a difference, not a
Okay.
mutation.
Okay, it's still a mutation.
Okay, let's just go on because
It's the same
we're
word.
not going to get it. It's clear we're not going to get anywhere with this. I hope
Nobody, nobody
reasonable
is
people listening
no,
will
okay.
just follow this.
Nobody is assuming that this genome right up here, came from this genome right here. Nobody's assuming anything. We're just showing you that there are two differences in this sign
Good.
between humans and chimpanzees.
Difference.
Okay,
There's a difference. That's an
right.
observation.
Two different,
Mutation means you're assuming that there was a different starting point.
right. So we go down to gorillas and we find, I think, 4 or 5 differences between humans and gorillas. And I think I haven't done humans and chimps, but let's say there's 4 differences between humans or between chimps and gorillas, right? So now we have these differences, right? And then we go on and we look at orangutan, and orangutan has 7 differences. And then we go down and we look at mouse, and a mouse doesn't even have this sequence at all. It's not there in the mouse. So we know we have those differences. So we stack those things up, okay? And they start to look, and then what you can do is you can project backwards and come up with what you think was an original, basically genetic structure for this thing, but you're never going to be right about that, right? But that's your baseline. And then you go ahead and you look at the amount of time that we're saying that chimps and humans, between now and when chimps and humans had a common ancestry, right? And between chimps and gorillas and humans and gorillas and all of that, and orangutans. And we have some other reasons for believing that particular timing happened. And then we look at this and we find that it matches. And that's all we know. Okay, so we know that we have a perfectly plausible story here about how you would start out with one genome and you would branch out into 2 populations, and then one of those would branch out into 2 populations, et cetera, and all along the line, one at a time, for the amount of time that we are projecting and that what we find according to other evidence. And this story matches up perfectly. And it does it over and over and over again. And in this sign that I'm showing you right here, this is in the middle of an intron, in the middle of a blood clotting protein. And there is absolutely zero indication that this has any function at all. So what we're likely looking at is mutation. You do believe in mutations, right?
Yes.
Okay. So you already believe in mutations. Why are you pushing back on chimps having different mutations than humans? So suppose God made us both the same. And what we're looking at is mutations, and chimps have twice as many as we do or something.
Right, because I'm not saying there can't be a mutation in a human or a chimp. Of course there can. What I'm saying is you're assuming that at one time there was a common ancestor between these, right? And that the differences that you're seeing between them are a result of these mutations. And I'm pushing back on that because that may be the story you believe, but I don't think that's reasonable.
Okay, you're assuming your hypothesis. Okay, so we have a hypothesis. That is that chimps and humans had a common ancestor, right? So that's our hypothesis.
Okay, sure.
Okay. You have to assume your hypothesis and then go out and look for two things. Okay, you look for evidence that supports that hypothesis, or you look for evidence that refutes that hypothesis. You look for something in this genome that says that, no, this can't happen that way. That couldn't happen. And so far, this what I'm showing you matches our hypothesis.
Well, I do think we've found stuff that says, no, it can't happen this way. But Andrew says, how do you differentiate between a mutation difference and a creation difference? You know what? I'm asking you how you guys would know if it's a natural difference or a mutated difference. If you're not assuming, if you don't assume a common origin, if you just say, look, we're just here to look at the facts. And so let's just suppose we're not assuming that the creation and we're not assuming the common ancestry. How would we tell if something is a mutation or if it's just a natural difference between organisms?
What is the difference between those two things? Okay, if we were looking at those two things, that's what Andrew's asking you. If you're looking at something like that, you're looking at, I could show it to you again. You're looking at these two strings that are different, right?
Right.
Okay, tell me what it would look like if it was a natural mutation.
I don't know. That's why I'm asking you guys.
Well, it wouldn't look any different.
Okay, so then what you're showing me, then you're saying it wouldn't look any different. Therefore, this does not confirm your hypothesis, nor does it confirm mine.
Well, what is your hypothesis?
It doesn't that God created. So it doesn't. But we don't have evidence in either direction just by looking at the genome lined up like this.
So which one did God create? Did he create the GGCT? Or, which one did he create?
I don't know. But the whole point is you're trying to show me the evidence but look, and Andrew's kind of saying you're claiming that these could be created. The burden of proof is on you to show how these created difference will work in the. But remember, in this overall discussion, what's trying to be shown here, Mike is trying to show me the evidence for evolution. And I'm looking at what he's showing me, and I'm saying that what he's showing me fits equally with my story and his story. So I'm not seeing the evidence as pointing toward favoring either story. So there's no evidence here.
Okay, but you haven't even given me a story. Okay, so what are you saying here? That God created that top thing the human thing and the chimp thing just like that, and there's no mutation at all here? There's been no
I'm saying
mutation.
I don't know, but from this lineup, I
Hey, wait a
can't
minute.
tell.
That's not a story. If you don't, if you flat out don't have a story, what is your story? Okay, I don't know what your
I'm
story
saying,
is.
well, I don't have a story for each one of these. All I
Well, then
have is an observation.
how do
I
you
have an inconclusive observation. So, I mean,
okay, that's what
you're
you have.
asking me to draw a conclusion where I don't think, well, I'm not going to say this favors my story. It doesn't. It's just
Right.
an observation of a difference, right?
Right. So
And
it's not
so,
evidence for creation, right?
no, it's not.
But it is evidence for evolution.
No, it's not.
No, it is, because here's the thing, Rebecca. Okay. We're making a prediction. We're saying that the human is going to be more like the chimp than the human's going to be like the gorilla and the orangutan. And we're saying that when you observe these things, you're going to see more differences between humans and gorillas than you're going to see between humans and chimps. Now that is a prediction, and here it is. Here's the observation that backs up the prediction. So this is evidence for common ancestry. And you just admitted that it's not evidence at all for creation, because creation could have just done anything. God could have created the chimp and the human exactly the same. He could have done it entirely backwards. And since then, all this stuff is mutated and jumbled around, but you don't know because you're not making any prediction at all.
Okay, well, let me ask you this. Is the reason that you believe humans and chimps had a common ancestor? Okay. What is your reason for believing that?
The amount of homology between our anatomy, our development, our embryology compared to other animals.
Okay. So it wasn't a prediction. See, you said we predict that humans and chimps would have a similar, but now you're saying, oh, wait, actually, the reason we believe they had a common ancestor is because we looked at the genome and the similarities. So which one is it, a prediction, or is it this is the reason that you thought it in the first place?
Okay, we look at the similarities between humans and chimpanzees, right? Number one. So we see a lot of similar anatomy, a lot of similar development, okay? And then we would predict, basically, that our genomes would be pretty similar too, right? But it's more than that. It's more than that. Now we get another organism, a gorilla, and another one, an orangutan, and another one, a mouse. And we look at those same similarities. And we see that same homology in this in these genes, right? And then we look at genetics and we figure out how mutations happen. And we can have some pretty good idea about what the rate of those mutations happening is from the whole field of genetics, basically. It's a complicated thing to find that rate, right? And then we look at this and, we don't even need the rate. Okay, all we need is this morphology, and it's borne out in these genes. But then we look at this and we say, okay, to go from a T to a C, we go from a T to a C. There's no magic involved there. That T can go from a T to a C. We've seen it happen in the laboratory. So we know these mutations can happen. So all of a sudden, it's like, okay, how did these organisms come to be? Okay, so then we say, they could have had a common ancestor. That's our hypothesis. Is this evidence for that hypothesis? Yes, it is. You have to admit that it's good evidence for that hypothesis. If you don't see it as good evidence for that hypothesis, then you don't understand anything that I've said for the last half hour, because this could happen this way. It could have happened this way.
Yeah, it could have.
Okay.
It could have, but you haven't given me a reason to believe that it has. But Speed, I want to go on from this because I feel like we're not getting anywhere. Is there anything else? We've been going for? No, it's because I don't think you're being reasonable.
No, I don't
so
think.
I feel like we're just going to keep going in circles and circles. So
I am being so reasonable, Rebecca, and you're not seeing it. Okay, Okay, let's pretend for just a minute that these two top lines are the entire genome for humans on top and chimpanzees on the bottom. We have the entire genome, right? Okay. Okay. We look at this line and we find one difference, and that is right there.
Okay.
T and C. And we say, okay, that is the difference between humans and chimps, right? Okay. Now, if we look back at a common ancestor, if we have that hypothesis, okay, we're going to have another possibility for, we're going to have another string back here somewhere, basically. Hypothetical string, right? We know that that T can change to a C. That is evidence for our hypothesis that that can happen. If that couldn't happen, then our hypothesis is gone. There's no way that we could have had a common ancestor. So we have a hypothesis, and this is evidence for that hypothesis. And now if we look at a third organism that's further out on the tree, an outlier, okay, and we find even more differences to that one, well, then that matches our hypothesis too. So that's evidence for our hypothesis. So, I mean, this could have changed from, we know that if we started with some perfect genome that we could have gotten from human to chimp and chimp to human. It could have happened either way, right? I mean, it could have been that everything was chimps back then, and some mutation. Suppose my hypothesis was that the entire world was made of chimps, everything. That was the only life form there was, and all of their life forms evolved from chimps, right? And so we look at humans and we say, oh, well, we're very little different, so we must have evolved pretty rapidly from chimps because we're very little difference. And this would bear that out, right? This would be evidence until we looked at all the other genomes, of course, and the rest of the story. And then, of course, that would not make a lot of sense. But anyway, you have to understand that this is evidence for our hypothesis. And if you don't, then you're not understanding what a mutation is. There's something wrong. There's something about the structure of your thinking that's preventing you from seeing that this is highly possible. That we could go from a pretty similar common ancestor and end up with all the primates, that could have happened naturally. If we're just looking at genomes, right?
Okay.
Right?
Is there anything else you wanted to share about your reasons for believing in evolution?
Let's see. You want all 100,000 of them, or should we try to end a little sooner then?
Yeah, we might need to end a little sooner.
Okay, because I have 100,000 of them. Yeah, I just.
All right. Well, then we can consider this episode 1. All right. Well, thank you for being here, and thank you everyone in the chat. It's been great having you all here. I've really appreciated having an audience, and you guys have been great with your comments. Thank you.
And we're going to do an after show where we dissect you.
Oh, good. Go for it. I love it. Okay. All right.
Okay.
Have a good day. Thanks, everybody. Bye.